Assalamualaikum and hi everyone. In this video, I want to show you how to answer the tutorial question of first hour and second hour. But before you watch this video, hopefully all of you already done answering the questions or at least try to answer the question. Okay, we will start with our first question. First hour, non-face to face. The question asks you to write the differential rate equation for the following reaction. Given to you all of these equations, so what you have to do is you have to write the differential equation. Okay, so we start with A. So as I already discussed in the video, to write the differential equation, first you must include the word rate. Because term rate of the equation is about rate. Okay, that relates each components in the equation. So you look at the equation, first equation, you have to consider the coefficient. This is 1, this is 1, this is 1, this is also 1. So for to write the differential equation, rate equal to, so this is our reactant. Reactant will decrease in concentration, so d I minus over dt equal to negative d OCl minus over dt. Okay, now product equal to positive dCl minus over dt equal to positive dOI minus over dt. So this is how to write the differential equation for question A. This is A. Okay, now try to discuss question B. Okay, for A question, all the coefficient here are 1, but for B question, we have 3 O2 and 2 O3. Means 3 mole O2 disappear, 2 mole O3 will be formed. So to write the differential equation, write the terms rate equal to negative 1 over 3 d O2 over dt equal to positive 1 over 2 d O3 over dt. Alright, so we have to consider the coefficient to be put into our differential equation. C. Okay, so we write R equal to negative 1 over 4 d and h3 over dt equal to negative 1 over 5 d O2 over dt equal to positive 1 over 4 d NO over dt, and we have lastly positive 1 over 6 d H2O over dt. Okay, finish for the first question. Okay, next we go to our face-to-face question. Okay, number 2, we start with number 2. Consider the reaction for ammonia plus 5O2 gas to produce 4NO gas plus 6H2O. First, ask you to write the disappearance rate of oxygen in 0.02 molar and SN1. Determine the formation rate of H2O and disappearance rate of ammonia. Okay, this one, the question wants you to relate between the differential equation and also the disappearance rate of oxygen. The information given from the question is disappearance rate of oxygen, and the question asks you to find out the formation rate of H2O. Okay, firstly, we take out the information given. Okay, disappearance rate of oxygen, as oxygen is the reactant, so it will be negative dO2 over dt. Okay, this is rate disappearance of oxygen. Okay. The question wants you to calculate the formation rate of H2O. So now we have to relate between H2O and O2. So look at the equation. So when this kind of question, you have to use the differential rate equation. As differential equation will relate all the components in the equation. So from the equation, okay, let's write the differential equation first. Okay, R equal to negative 1 over 4 d and H3 over dt equal to negative 1 over 5 d O2 over dt equal to positive 1 over 4 d and O over dt equal to positive 1 over 6 d H2O over dt. Okay, this is a differential equation. Okay, I want you to not confuse between the term R here and the disappearance rate. Disappearance rate is individual rate for oxygen. Okay, R is rate of reaction. So this value is not same. This 0.02 mS/1 is this value. Okay, so now we want to relate between O2 and H2O. So between this and this. So we relate negative 1 over 5 d O2 over dt equal to positive 1 over 6 d H2O over dt. So we already have this value. We just substitute into this relationship. It will become negative 1 over 5 times 0.02 equal to positive 1 over 6 d H2O over dt. This is the one that we are going to solve this equation, and you will find out the d H2O over dt. Okay, next I want to show you how to answer question number 2. Given to you the equation and already stated that it is second order for NO and first order for Cl2. The question asks you by what factor does the rate reaction increase if each of the following changes occur. Okay, first thing you have to do is you have to write the rate law. Okay, so for the rate law here, we have R equal to K concentration of NO to the power of 2, as it is stated that second order with respect to NO, and Cl2 to the power of 1, as it is stated as first order for Cl2. Okay, by doubling both NO and Cl2. Okay, now look at question said we double, means 2NO, and double Cl2 to Cl2. Okay, take note, this is square or to the power of 2, this is to the power of 1. So you can factorize by bring the factors of reactant out from the concentration. So 2 squared, you have 4, right? So we have 4 times 2 to the power of 1, 2, K NO squared Cl2 to the power of 1. So this is our rate law. Same as I write it at first. And 4 times 2, we get 8. K NO squared Cl2 to the power of 1. So from this calculation, we can see that by doubling the concentration for both NO and Cl2, our rate of reaction will increase by 8 times. Okay, got it? Okay, let's try to answer for B. making Cl2 3 times higher. Still, we have to refer to our rate law. So 3 times higher means we make the concentration of NO constant, but we increase the Cl2 3 times. So Cl2 3 times 3 Cl2. Okay, so for this question, for this calculation, 3 to the power of 1 is 1. So 3K NO squared and Cl. So we can see that our reaction become 3 times higher or 3 times faster or increased by the factor of 3 when we increase our concentration of Cl2 3 times higher. Okay, lastly, making NO 3 times higher while halving Cl2. Still, we have to refer to our rate law, R equal K NO squared Cl2 to the power of 1. So we making NO 3 times higher, 3 NO squared half Cl2 to the power of 1. So we factorize 3 squared, we will get 9, right? 9 times 1 over 2 K NO squared Cl2. So we will have 9 over 2 K NO squared Cl2. From this calculation, we can see that the rate of reaction will increase by the factor of 9 over 2. Or you can calculate it as 9 over 2 is 4.5.